objective is to develop a holistic HVAC approach for a multi-story smart building. Second, merging mechanical and natural ventilation methodologies. And third, primary goal, guaranteed thermal comfort and optimal indoor air quality.
First one, proposed system. The proposed system is centralized VRF architecture. VRF stands for variable refrigerant flow. Essentially, this means a single large outdoor unit can efficiently manage the cooling and heating need of numerous indoor units throughout the building. For the mechanism, it uses an inverter-driven compressor because it can continuously vary their speed and output. This allows the system to precisely match the exact building load at any given time, avoiding wasteful power surge. For the definition, VRF is advanced HVAC technology that uses single outdoor unit to supply multiple indoor units. Think of it as a smart, adaptable plumbing system for refrigerant. For the key advantage, the first one is high energy efficiency, low power consumption during a part load operation. This can save energy and save money. For the second one is excellent zoning control, independent cooling for each room. This means occupants can set their own comfortable temperature without affecting other areas. For the quiet operation, smooth running compressor to prevent sound pollution. The compressor is built in the system that the operation can be silent as possible. For the flexible installation, small piping size allow unit and sophisticated building aesthetic.
The location of the building is in kawasan perindustrian Cendana Sungai Petani. It has a direct link to the Lancongan Timur Eastern Bypass and Plus Highway. And the zone of this building, it has a strategic zone. Is in industrial land suitable for heavy operation and logistics. This building has a 7 private office, conference room, foyer lab and break room. So it also has support facility, includes ADA restroom and general bathroom. The layout of this entire building is 2,216 square feet. Building also use double glass window for its use because it has a noise reduction. It minimizes external industrial noise for a focused work environment. Also, it has energy efficiency because it reduces heat gain, lowering the burden on the AC system. Also, it's crucial for location in industrial area because it can minimize our electricity use because of the heat and noise. Furthermore, it has a natural ventilation. Also, we can say cross ventilation. Cross ventilation works by utilizing the pressure differential created by wind around a building. Inlet windward side, the wind creates a positive pressure. It's like a push from the outside on the side fencing. The wind forcing the fresh into the room. It came from the outside of the building and go through to the building. So the outlet one, leeward side, the wind flow creates negative pressure suction on the opposite side, pulling the stale air out of the room.
The selected unit type is ceiling cassette. The model considered for this type of air conditioning unit is Daikin FFC FCFP series and Hisense AUC series. The refrigerant is White Rod RT2, eco-friendly with lower global warming potential. This can map offer success. For the full flow airflow is because why we chose ceiling cassette is ensure even distribution of air in square rectangular office. For the aesthetic, recess into the ceiling and saving wall space. The technology in the ceiling cassette is built-in condensate lift pump and human detection sensor so that it can detect if the room is empty or have an occupant so that it can turn on or turn off.
This slide will show you the dimension of the room and we calculate the volume of the room. Next, we proceed to the calculation. First of all, we need to calculate the heat loss for wall, roof, floor, ventilation, and the occupants. After that, we need to calculate the total of heat loss. For your information, the U value for each of them are different using the standard required. Using heat flow rate formula, we determine its CFM. Then, to calculate ventilation rate per hour or ACH, we use formula airflow in CFM times 16 over areas times heads or over the room volume as shown in this slide. To determine the suitable air conditioner for the room, we need to calculate the horsepower required by the room by using cooling capacity formula. With heat factor equal to with heat factor equal to 18 and BTU per hours equal to 9,500, then we get the horsepower equal to 1.4, which nearest to 1.5 HP. This slide show you the occupants load for each room.
We successfully designed a mechanical ventilation system that fully meets all technical criteria and occupant comfort requirements. Our chosen system is the VRF, Variable Refrigerant Flow System. This is the optimal choice. Why? Because the VRF system offers two main advantages: superior zoning control, which is allow precise temperature adjustment for each office space individually, and high energy efficiency through inverter operation. More importantly, this design ensures full compliance with the standard recommended by ASHRAE. This is the success of our conflict resolution approach. We managed to balance the need for maximum comfort with minimum energy use. Switching to the long-term strategy and sustainability, we ensure that this project is not only efficient but also responsible and future-proof. First, in terms of integration, our VRF system is integrated with a DOS or dedicated outside air system. This integration is key to ensuring excellent indoor air quality (AIAQ) and compliance with ASHRAE standard. Second, our building fabric strategy involves that the use of double glazing. This measure reduces heat load and noise from the industrial area, thereby enhancing the overall efficiency of the system. Third, we are committed to sustainability through the use of low GWP global warming potential refrigerants. Overall, this system represents a solid, future-ready investment. It offers low life cycle cost (LCC) and high adaptability should change to be building layout be required in the future.
Here is the conclusion of our project. First, we successfully designed a mechanical ventilation system that meets all technical requirements and ensure indoor comfort. For the final justification, the VRF system is selected because it offers better zoning control and higher energy efficiency compared to another system. This system is also integrated with DOAS and double glazing to support sustainability and comply with ASHRAE standards. Overall, this solution provides strong long-term value, a reliable and future-proof investment with low life cycle costs and good adaptability for future needs.